Good morning, everyone. I would like to welcome you all for the two-day FDP on the deep learning technology. It's time to introduce our PencilBit. PencilBit is a leading providing a comprehensive academic and research support services committed to the forecasting innovations and academic excellence. Our mission is to express, especially in the phase where innovation meeting expects, we provide ourselves to deliver the high quality solution across the various domains. Research publication supports. We assist the publication research paper in the prestigious Scopus and the Web of Science indexed journal and covering the various area of the discipline such as engineering, management, and the commerce. Patent and intelligence property services and academic publishings, workshops and trainings. The Pencil Bits regularly organize the seminar, workshops, and faculty development program for the faculty members, academician, and the research scholar, ensuring the continuous professional development and the knowledge sharing with the academic committee. Our dedications to the quality and innovations and the client satisfactions and success has to be established as the trust partner in the academic and research field. It's time to welcome our today's speaker, Dr. S. Anandi ma'am, has 10 years of teaching experience and the project experience. She has completed her ME and PhD in the computer science engineering from Annamalai University. She also worked as the fellow in the UGC member research fund project. UGC member from Delhi. With the grant of 30 lakhs, she has published 30 plus research articles, 10 patent. She is also 123 citations and 7 H index and 4 I10 indexed. She's also participated in more than 25 international conference and won the Best Paper Award. He is a major area of interest, including the machine learning, artificial intelligence, and digital twin learning, and one API C essential, CUDA to the CS, CYCL, and Intel regarding the toolkits. She is an author of 2 books in the artificial intelligence and cybersecurity. She also completed the various industries internships and the artificial intelligence, machine learnings, Python, and data analytics. She served as an editor and resource paper and the keynote speaker at the various conferences and events. She is in a lifetime membership of ISTE and she currently remains as the manager of the Center of Excellence of the Cloud Computing and the coordinator of the Center of Future Network and Digital Twin. Welcome you, ma'am. Welcome you, ma'am. Anandi, ma'am. It is audible, ma'am. Anandi, ma'am. It is audible, ma'am.
Ma'am, is it audible?
Yes, ma'am.
Yeah. Good. Good.
Ma'am, it is audible, but it is not clear, ma'am.
Yes.
Hello, ma'am.
audible? Ma'am? Coming? Ma'am, am I-
Good morning, dear professors. I kindly request everyone to wait patiently because there is a network issues. We will rectify that.
Am I audible now?
Yes, ma'am.
Now? Ma'am, am I audible now?
Yes, ma'am.
Yeah, ma'am. Sorry for the inconvenience. I'm Dr. S. Anandi. Is it audible clearly now?
Yes, ma'am. It is clear now.
Okay. Thank you all for your patience for a few minutes. I'm Dr. Anandi from Sri College of Engineering. So I'm a research head and assistant professor in CSE department. So without making delay, I'll get started into the concept of deep learning. Does the screen is visible?
Yes, ma'am.
Okay, ma'am. So yeah. So today we are going to discuss about deep learning, the difference, the comparison between deep learning, machine learning, and artificial intelligence. We are discussing advantages, and need of the deep to the convolution neural network part. So coming to this deep learning is a type of artificial intelligence and it's a kind of neural network. The main motive of this deep learning is to make the system think like a human. So it is main category like deep learning will comes under the subdomain of machine learning, and machine learning is a subset of artificial intelligence. Whereas coming to this artificial intelligence, so it is not a real intelligence, it is an artificial intelligence. So we are making this system or the machine to think or to mimic like a human behavior so as to make some decisions. Based on the decisions, we will be doing some computational process or real-time applications. So then coming to this machine learning part, machine learning, before going to that machine learning, in order to achieve this artificial intelligent concepts, like we want to make the human-like behavior, for that we need some algorithm, we need to train our data, we need some data to train, and to train that we need some algorithm. That can be achieved with the help of this machine learning. So this machine learning is So deep learning is a method, artificial intelligence, that teaches how the computer to process the data so that data right. Deep learning is the structure of the brain, classifying is an apple or it is an orange. But for the system, it is not that easy to identify the difference. So when you are going for this machine learning concept, So when we are going for this machine learning concept, what we will be doing is we will be giving some features. So like the shape of the apple or the color of the apple, we will be feeding with hundreds of data to the system. Then only the system can decide that either it is an apple or not. So for example, I am comparing this apple and orange means I want to train my system in the machine learning. I am telling the comparison between the machine learning and the deep learning. So in the machine learning, what we will be doing is we will be giving the size, the shape, the feature of the data. Okay. After giving these data, the system will be trained with multiple nodes and discuss. We want to train data with the feature. So we want to extract the specific feature. So that only our system will be identifying whether it comes under this category or category. Classification takes place like that only. But when you are coming for deep learning, this process will be an activation, so we will be doing easily. So that is the major difference between this artificial intelligence, machine learning and deep. Without the human intervention, the deep learning pick the So this we want to we want to process a massive, or when we want to predict like medical application, diabetics detection, cancer detection, and all, we process large amount of data, large volume of data. So we want an accurate result. So if a person is identified, so the person is not having a cancer and they were identified as a cancer patient means, so it's vice versa, everything is a problem when we are going for a medical applications. So for that, we want to train massive amount of data. To process this massive amount of data, we need huge storage space to process. So in order to avoid those things, this deep learning is giving a better solution for this. Another reason is with the Python or PyTorch, the PyTorch and all are used Facebook. So this Python, PyTorch and all, they will be implementing just within 3 4 days of spending. We no need to know much about the mathematical notation of learning concept and all. Just by importing the libraries or utilizing the open source facilities, we can develop our own project or our own deep learning algorithms in 3 to 4 days. Anyone can learn easily. So that is the main, everyone is moving towards deep learning. The hardware advancement also. So earlier days and all, we had only limited amount of, now we have GPUs, everything we can process. So in order to process this, earlier days and all, if we want to train millions of data or 10,000 of data, we need 2 3 days or a week to complete the process. Now the computation became so fast. We are going with this cloud platform and all. We have a massive storage. We can go for and the concepts and all. So there we can store massive amount of data and we can process. These are the main reasons. It's very compatible to use these, and without the human intervention, we can convert our data into a required result. So these are possible with this deep learning. So the advantage of this deep learning is it is high accuracy. It will provide a high accuracy and automatically discover and learn the relevant feature from the data without any human involvement. So this scalability, flexibility, and all talking about, it can scale large complex data easily, and from that data we can learn which classification under what and all, everything happens easily. So we are learning from the massive amount of data and we are making decisions accurately. So the flexible talks about it is it can be applied to a range of tasks. So it is easy to handle variety of images, speech, or whatever. It is applicable for all the things and all. So these are the main advantages of deep. And so if I want to create a if I want to create a digit recognition system, every way of writing will vary from person to person. I'm asking 4% to write. Types and then a single person will write a rash, will be writing some, we will be writing some other type. So now identity patterns, what here deep learning proposes is, as giving some examples with this, we will go for image regarding. So this 9 will be interpreted as, here I have used -1 plus 1. So +1 are the data present and -1 are the not data. We can use zeros either. So here I have written 9. So wherever the value present, so everything will be considered as pixel here. So in the pixel, wherever the data present, I'm marking as a 1. Wherever non-data are considered as a -1. So here I'm plotting. So this will be considered by the system. If I'm giving training like this means, in normal machine learning, what it will do, it will consider it as a variation. So this is some variations, right? Here I'm having one loop, one straight line. So here I'm having a loop that circle for 9, and here I'm having a straight line. Then I'm having a vertical or horizontal line, or someone else will skip only with this. So there can be the variations, right? So these variations cannot be predicted that much easily. So in order to make it possible, we want to train huge amount of data. So we want to train all the varieties of data in the machine learning. While coming to this, what we are going to do is, we are going to identify or separate it as three different patterns. So here I'm dividing this loopy circle pattern into a single block, and another again I'm trying this into other neurons, and again I'm trying this with another neurons. I'll be talking about neural networks and neurons after this. So by completing this, we will be framing this 9. It is the outline of 9 alone I have given. If it is for 8, we will be having 2 loop circle pattern. So with that, we will be training like this. So to differentiate these and all, we will be, it is easy for the convolution network, and we will be applying the filters for this. So that we will be discussing in the neural network concept. So these can be easily identified, and they are easily trained with the ReLU, and we will be applying the maximum pooling and all in the convolution neural network. So with that, it can easily identify. For a human, it is easy to identify. So as to make the system also to identify easily, we are applying the filters here. So we will be applying some filters to identify this. After that, we will be applying, we will be giving this into the many layers. We will discuss that later. Coming to this neural network, so we will be having a mathematical model. So it mimics the structure and behavior of the human neural networks. So human can accurately predict within a fraction of second. So the neural network concept is so as to make the system to predict as much as like a human. So how it is possible is, I want to make whether this is a lion or do some face recognition process. So what I'm going to do is I'm taking some group of people. These people were not aware about the tiger, or it's just for imagination. You assume that these people have never seen the lion or tiger, some animals and all they have not seen. So we are asking them to identify the lion and tiger and classify how much accurate it is. So it is not possible for them. How it is possible is, how we are making the system to train is, so we are giving these group of people, each one we are allocating some different tasks. So what I'm going to do is, so this person one, so assume this as a person A. So for person A, I'm telling you filter only eye region. So how the eye will be, that thing I'm giving input to this particular person. For this particular person, I'm asking to classify or identify only the nose feature. For this person, I'm telling only the mouth region. So we will be plotting that boundary box, no? So that boundary box, what are the data will be coming, that one we are going to make these people to identify. So one person is concentrating only on whether this eye belongs to this lion or not. So whether it is a tiger or lion, they are classifying. So here this person, what he is doing is, he is focusing only on the nose region. So this person is focusing only on the ear region. So I'm allocating some other person to identify and collect the data from them, and check whether everything is happening in a correct manner or not. So what data they will be giving is, so each one will become an expert. So you assume this person A will become an expert by just seeing itself, because he is going to give, he or she is going to give only the data in that ranges from 0 to 1. So if it is similar to something, the image that captures means, they will be giving 0.5 or 0.1 and all. But here they are giving 0.3, means this is not a tiger, right? So they are giving the value as 0.3. So the nose feature, the person 2 will be deducting at the nose feature, and he is telling how much accurate this is. So they are going to tell the values in the ranges of 0 to 1. So we will be fixing that 0.5 as a median. So less than means that will not comes under, that will not falls under the category, and greater than means there is a possibilities, and that will fall under the classification which we are doing. So now coming to this, here I have shown a linear regression model. So you assume here I'm having a person age and the insurance, whether they possible, the probability whether they can have this insurance or not. So I'm going to create a insurance prediction, whether a person with 20 age can have an insurance account or not, like that. So now I'm having a scatter plot here. So I have plotted my values over here. I have drawn a linear regression model here. So the problem with this is, if I am including a new value with this, a person with age 90 means, so the linear, my plotted as like this. So I will be getting some misclassification rate. To avoid this misclassification rate, what I am going to do is I'm going to plot a function like this. So sigmoidal curve I am going to plot. With this sigmoidal curve, so you look at this. Here I missed so many data. When you come over here means I'm covering maximum part of the data. So here we have missed few data, but still some 90% of data has been covered over this. So this range of sigmoidal curve, we will be calling it as activation function. So the value I have plotted here, the less than 0.5, for this less than 0.5, the neuron will not get activated. For greater than 0.5, if you look at this sigmoid or logic function over here, here only my neuron get activated. So we are talking about the neural network concept. So if a neuron get activated, then it is going to be under that category. If the neuron is not or less than this 0.5 threshold which we have fixed, so it is not, neuron will not get activated. So this sigmoidal function only we will be calling it as activation function. So we are here is the equation
Excuse me, ma'am.
to compute the linear
Your slide
regression.
is not,
Yes, ma'am.
your slide is not visible. Your
Ma'am?
slide is not moving. Your slide is not moving, ma'am. Your slide
Okay, ma'am. I'll.
presentation is not
Yeah,
visible.
yeah, yeah, yeah. Okay, wait, I'll be showing you again. Ma'am, is it visible now?
Yeah, ma'am. It is now okay. Yeah, it is okay now.
Okay. Yeah, thank you, ma'am. So here I'm having a linear regression model. So, ma'am, is it visible now?
Yes, ma'am. Yes, ma'am. You can continue.
Yeah, thank you. So here I'm having a linear regression model, and here it is a logical regression model. So here I have plotted a sigmoidal curve. So this sigmoidal curve, which covers a wide range of data, and it will give accurate result. So in order to, we will boost, we will be adding the weights later. So to avoid these also, to make it more accurate also, we want to feed forward, and we will be giving error propagation, everything we will be doing with this. So when coming to this, so the ranges falls above 0.5. So whatever data falls above 0.5 means that there the neuron will get activated. If it goes below 0.5, the neuron will not get activated, which means it will be as a 0 and it will be as a 1. So that's it about the neural network concept. So next, you coming to this. Yeah, we come to this. Here we have identified for face region alone. Here what we have did is, so I have given 3%. One person is concentrating on eye region, another person is concentrating on nose region, another person is concentrating on ear region. So after combining all these, they will be coming to a conclusion whether it belongs to this particular categories face or not based on the values. So likewise I'm doing for the body also. So this is for the face feature. I'm doing for the body part also. I'm assuming that whether it has how many legs, everything I'm calculating, that also I will be going to give to some other different persons, and I'm going to analyze combinedly. Finally I'm going to produce the result. So you look at this overall this overall function. So here this first blue line represent the input layer. You assume like my pixel size is 1024 cross 1028, which means I will be having 1024 cross 1028 convolution network in the latest. We will discuss that. So that will be here. So this is your input layer. So from transforming from input layer to the output layer, so our output layer depends on our application, our input layer and the output layer will vary. So if I am going to find for digit recognition means, so there how many pixels I have, so that will be considered as a input layer. So overall the pixel, say if I am having n cross n means, so I will be having n cross n input layers. My output is going to be, if it is for a digit, so 0 to 9 digits we will be having. So I want to decide whether it is a 0 or 1 or 2 3 up to 9 I'll be having. So I'll be having 10 output layers. So in our case, if I am computing whether uh, it falls under a tiger or a lion means, I'll be having 2. If I'm comparing 3 objects means, so based on the result, my desired result, my output layer will vary. So from input layer to output layer, it won't achieve is in a single line. So we will be having 2 to 3 hidden layers. So we will be following through more number of hidden layers. So for this hidden layers, what we will be doing is we are propagating using the channels. So here you can see the arrows. So the neurons are connected like in the brain structure, like, so we are framing like this. So what we are going to do is, here I'm having my input data. With that input data, what I'm going to do is I'm going to communicate from one layer to another layer via the channel. So I'm going to communicate from one layer to another layer via the channel. This channel will be added with some weight. It is associated with some weight which we have predicted earlier. So that weight will be added to this layers, each channel. So it will be transformed with this. Here we will be having a bias. So after this bias, we will be transforming into other layers and all to achieve the output layer. So we are converting. So here, this is what we talk about now. So we are having a channel that is used to convert from one layer to another layer. So from input layer to the hidden layer to hidden layer. Once we achieve completely and we got accurate result, then we will be moving on to the final layer, output layer. So we are having 3 types. We are having many types of neurons. So we will be, so in CNN and all, we will be following linear feed forward. Feed forward means we will be moving only forward direction. So it is in a straight line and we are moving towards, and we are again moving towards over here. So it is a feed forward. So it will be going to be the straight forward. So with that, we will be obtaining some result. So we are having some other technique also. Error propagation. Here we have discussed, right? We had like the person is, so you assume this girl is going to be the person who identified whether this comes under this facial face recognition or not. So what this person will do is he will calculate, and the body part also will be calculated by some other person, and that will be given to another neuron. So that neuron will be telling like, no, it's wrong, you are not wrong, you are not right. So you go back and you again rework like that. They are reverting back again, and we are based on that error. So as human, we learn from the mistake. That same also happens here. That is error propagation. So with the error, we will be rectifying. So this is not a right answer, we want to redo again it, like that. They will be doing some rework process and all. That thing also, that is also a human behavior, right? So we will be learning from our mistakes. So once we are identified wrongly, then again we are redoing that work. That is also possible in this neural network concept. So coming back to this, so the values are attached to each channels. So each neurons, it will be passed to each neurons. So you will be having a unique number for each neurons, that is called as bias. So it will activate the function. So it is going to applied as a function node, so as to activate the activate function. So here we talk about activate function, right? So this for this, to achieve this activate function, we will be doing this. So the beauty about it is we are not going to take care of each and everything. This convolution system or the recurrent system, what we are doing is that will take care of it. We no need to do any part behind it. Then coming to this, so we had a number 9. Okay, once again. So I missed to tell few features here. We will be having a supervised learning, unsupervised learning. These and all will comes under supervised learning. So supervised learning means we are going to label the data. So this is going to be like this. So we are going to train the system like how we will be giving training to a baby. So for a baby, we will be giving some photos. You imagine the 6-month baby and all. We are showing that flashcards to train the baby. This is a cat. This is a dog. This is a bird, like that. So we are going to give training to the system, like how we are going to give training for a baby. So we want to label the data. We want to give some input to the data. We want to give how it is going to be, like that. Some features and all we will be giving. After that only the system can identify whether it comes under this category or not. This is going to be the supervised learning. When coming to this unsupervised learning, so we are not going to give a labeled data, so we make the system to decide on their own. While the other one is reinforcement learning. When coming to the reinforcement learning, the reinforcement learning is like a trial and error method. So you imagine like we are playing a temple run game. So when I first very beginning I try to play a temple run game. On that day I don't know how to play in that. So when I click the press, so it starts to run. The monster starts to run. So when a rod comes or wooden like obstacle comes, it's track and fall. So we learn from the environment. So if I hit means I am going to fall. You imagine the maze game also. The person is going running towards. If the block occurs, then he will be falling, and again he will be coming back. So this reinforcement learning is good, very good for gaming development and all. So they are learning from the environment based on the trial and error. We will be calling it as reward and punishment. So if I'm climbing the coin means that is a reward. If I'm falling in the water means that is going to be the punishment. So again my life starts from the beginning. This will comes under this reinforcement learning. So coming to the convolution neural network, I'll show you a page once again. Yes. Is it visible?
Yes, ma'am.
Okay, ma'am. Yeah, coming to this convolution, we will be applying ReLU and all. So we will discuss about it. So this pooling and all, we are having maximum pooling, minimum pooling. So you assume that a pixel of data over here. Here I'm having a pixel of data into my number. So coming to this number, my value will be plotted like this. So we will be computing the activation function. So where the value of this particular pixel is present means it will be generated a value like 0.5, 0.3 is. Out of that, we will be parsing 2 cross 2 square means, so 4 region alone will be computed. With that, we have plotted the probability or possibility of values. So the activation function and all we will be defining here. So with that data, what I'm going to do is, I'm going to find the maximum of that particular number. So that maximum number will be assumed, and that will be computed with this maximum pooling. So this maximum pooling So each person's decision will be given as layer. So one person is identified. So this loop and all we are having now. So this zero and this looping and this horizontal line and all will be given as input, and that will be aiming at layer. That layer will be as that layer will be given to as input to the next hidden layers. Likewise we are repeating, and after that only we will be achieving. So in order to reduce the size, because we will be having n cross n size of the data we are going to plot. So to overcome that, what we are going to do is we are going to reduce the size with this pooling method. So after completing all these, we will be converting into a classification technique, whether it comes under that category or it comes under this category. So this filtering process and all we will be giving to this. Okay, let's discuss about CNN. Before we discuss about the CNN, let us talk about. Let us discuss about this again. If you have any doubt regarding this, we can discuss. So far we have discussed about the introduction to deep learning and the comparison between the deep learning with the machine learning and the advantages, disadvantages, applications. So they are highly applicable. It is applicable. Oh, I missed to tell the applications. So we can give the application. Sorry, we can provide the healthcare applications. So we need high accuracy that we have discussed. It is also applicable for image processing, speech processing, text processing. For autonomous vehicle, we can use this deep learning approach. So only the deep learning is for this autonomous vehicle and so many sensors we will be capturing each and every the distance and all we will be calculating everything. We want to train the system, so we want to analyze so many things. Not only analyzing the front, every side we need to analyze. So when developing a application like Tesla car and all, so we need to give 100% result, so else it may lead to some. And so then we talk about the activation function, how it is working. This, um, do you have any? Did I discuss anything regarding this? Furthermore, yes. Did I get clarify? Karthik, Karthika, is it audible?
Yes, ma'am, it is audible.
Um, uh,
Ma'am, your voice is breaking, ma'am. I'm not able to clearly hear you. Your voice is breaking, ma'am.
Ma'am, yes. Yes, ma'am. Yeah, hello.
Your voice is not audible, ma'am. It is not clear.
It's not
Break.
audible.
Yeah, yeah, breaking.
Yes.
Network issue, it seems to be. Network issue, it
Okay,
seems
okay.
to.
Now only or okay, okay. Ma'am, connect after 10 minutes of break. I'll I'll move to some other place or I'll check with the team. Is it okay? Is it audible now?
Yeah, now you are audible, ma'am.
Ma'am,
Now you are
okay, ma'am.
audible.
From where it
But
is not audible, ma'am? Which one?
just just
From
a few
where it
minutes
is not
back,
audible?
your voice is breaking.
Okay, 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 ma'am. Yes. So far we have discussed about the deep learning and how the background process of it and the advantages, disadvantages, applications, then what are the neural networks and how activation function will be working, the core concept behind the neural network, how it is happening. So discussed anything about mathematical notation. So we have just discussed the background scenario, how it because when for the Python program and all, so just with lines I can develop my linear neural network. I wanted to develop few lines of the core concept behind it is very mandatory. System can tuning and all we can execute. Yeah, that parameter tuning and all we can make possible only by adjusting the weight of the channel, so and so things. About the neurons and the activation functions. So before moving to convolution neural network, I wanted to know whether if you want to give any clarification regarding this. Yeah. Can you see my screen?
No, ma'am.
Okay, ma'am. Ma'am, shall we connect by 5 minutes? After 5 minutes of break, we will be continuing, ma'am. Is it okay? I'll check with my audio also. Yeah, shall we continue, ma'am? Shall we continuing? Um, Talking about evolution neural network. So, so screen is now once again. Yes. To this, we'll be comparing two different things. One is the recognition and or classification with that. It belongs to some category or not. So with this digit recognition, here what we are doing is, this one we have discussed earlier. So I'll be repeating again. So here what I'm going to do, person handwriting may vary from person to person, unique style of writing for each individual. Sometimes a person may even write in three, four handwritings. It depends on the timing and the hurry ups and all. So the handwritten pattern will get vary, but the number pattern, if I want to frame a number 9, I will have a line. That one we have discussed. So for that number, this here recognition in calculator and all, we will be doing only this. So some people will be writing like this. So we have to cover the entire range. So coverage written has to be overall, it has to comes under this. So we have drawn like this. So wherever the data present, I have marked as a 1. Wherever the data is not present, I have marked as minus 1. So with this pixel, so I have 5 cross 7. So I have a 5 cross 7 pixel value here. With this 5 cross value, so what I'm going to do is I'm going to extract the specific loop and a straight vertical line and a diagonal line. So the two, I need a loopy. So this one I'll be concentrating. So to obtain this, what I'm going to do is I'll be generating some weighted value associated with this. So in order to apply the ReLU and all, what I'm going to do is I'm going to slide my here. For example, I have given 2 cross 2 filter slide. I'm moving this 5182. So this particular range over here, this particular range over here. So here what I have done is pooling. I have done pooling is here I have done max pooling. Max pooling in the sense I have told you, right? 5182 out of these 4 value. What I am going to do is I'm going to find the maximum value among this. So 8 will be coming over here. When coming to this, I'm getting the 9 value here, and coming here I have drawn 3 here, and over here we have drawn 2 here. So the dimensionality of 4 cross 4 value will be reduced to 2 cross 2 value. So this is the with the help of this max pooling, I'm going to reduce it is like a dimensionality reduction method. So this sample example page we have shown. So when coming to this, what we will be doing is first we will be applying the loopy pattern. We will be calling it as filter. So this filter, what I'm going to do is, this is the wide range of my loopy pattern. To extract this oval shape in my pattern from the number, either it can written over here or over there, wherever it can be, but I want to recognize that loop pattern. So I have mentioned 1, 1, 1, minus 1. In the middle alone, I'll be having minus 1. So that particular part alone, I'll be considering as a loopy pattern. Here, the next value what I have done is, so the first pixel, what here I'm having is, so here I'm having 1. So the probability or activation function, I'm applying the activation function which we discussed in the neural network. So I'm applying all things and extracting the weight of particular pixel. So here I'm extracting some values. So the probability is like, it is like 0.11. It is 100% similarity, like that I'm getting some values over here. After getting all these values, after getting these values, what I'm going to do is I'm going to make this as a nonlinear type of reductional method. So I'm going to convert this as a 0.1 and 1. So whether I'm having a value minus values and all, I'm eliminating. So in here, what I have done is, so I'm making it as a nonlinear. So zeros and ones, and I'm having certain numbers also. So here I have first pixel you see means minus 0.11. So what I'm going to do is I'm going to make it as a 0 because it is a negative value. When come to this second one, it is a 1. So I have plotted that 1 over there. The third part is, it is going to be the negative range. So I have plotted as a negative range. So this 3 alone is going to reflect over here. The rest of the part, what I'm going to do is I'm going to make as a 0. So this we are making as a nonlinear format. So when we want to train and we want to make the speed up, it will be helpful for it. And then I'm applying the average pooling method. So I can use the max pooling method also. So certain cases I can use average pooling also. Whatever data I'm using here, 2 cross 2 slides. So we can go for 3 cross 3 and all, everything is possible. So it is just a sample we have shown here. So we'll be computing the average value of this and plotting over that. So 4 cross 4 is reduced into 2 cross 2. So with average pooling method. So whatever method we need, we will be applying. Here we will be applying only for maximum. So what I'm going to do is, you look at this first four boxes. So if you look at this means the maximum among this 1, 0 and 0.11 and 0 is going to be the one that I have plotted here. Okay. Then I'm moving my slide over to next window. So I'm just moving the frames. So here 0 and 0, 0, 0.33. So maximum among this particular region is 0.33. So that one only we will be plotting over here. Coming back to this, here if you see, we are moving the slide with this and we are moving the slide with this too. So here 0.11, 0.3, 0, 0, among which the data is going to be 0.33. So coming back over here, 0, 0.3, 0 and 0.33, among which the max pool is 3.33 I have plotted here. So when coming back to this last 4 region, I don't have values, so plotting 0, and here also I don't have everything at 0, so I'm plotting, and that's it. The filter with that I'm extract which is going to have my data. So that one I'm here. After that, I'm applying the ReLU, and after that, I'm applying the pooling concept. So this one will be always watching in the CN infrastructure. So plotted in a different, I have shown like this. So here, look at this. Here they have taken some cola image. So the Australian animal. So here what I have done is, here what I have done is, so as we earlier discussed, one person is concentrating only on eye region, the another person is concentrating only on nose region, this person is concentrating on ear region. So take out these pictures. So here concentrating only on the eye region, eye filter applying. So they are 1080. This is the which the region is identified in this particular two locational here. And for the nose region, I have extracted here, and here it comes, there is only one layer. So I'm going to make it as a filter, and I'm going to move forward this to the my neural network. So here I'm concentrating on ear region. So here I'm plotting it. So overall, this comes under the head. So my head, that is, it is a face feature which we have discussed. So from which I'm flattening the data, and then I'm applying to the pre-output layer. So that is the last hidden layer we are going to give. And from that, we are going to make decision. So with this, we will be performing the neural operations, then we will be extracting the exact result. So here I'm having a head region, and here it comes to this means, here I'm concentrating on hand alone, here I'm concentrating on head alone. Instead of concentrating on the entire region, I'm going to make a filter, eye filter, nose filter, ear filter, like that and all. And I'm going to pass it to the upcoming layer channel to the neuron, and the result has been obtained, which will be better like that. So this group of people, so this one we have discussed, right? So all the regions, so this is ear, eye, this is nose, this is ear. So this filters, or this is given to the convolution, that is the convolution layer is the input layer of this CNN, and I'm applying the pooling method that we have discussed. Either it can be average pooling or maximum pooling, we can apply this. And again, we are redoing this for the head. So again, so the picture is something different, like the region part has been changed. So in earlier picture and all, we had a face in the topmost region of my pixel, my image. Now it comes over the bottommost layer of the image. So now also the same happen, but the thing will be here is, so the region will be downwards. So here I'll be having zeros, everything. The next one is, so next I'm going to give this to again pooling. I'm going to redo this, and until I achieve whether it is a cola or not. So this is the convolution neural network. So the layers, if you have seen the website and all, if you are watching me, I'll be showing that also once again. So if you look at this one. This is what we talk about. If you look at this, yes, I'm giving 9 input. I'm giving this 9 as input to this system. Here, what will happen is, 9 is given to 789. The pixel size, something like depends on the pixel size. I have plotted 789 input layers. So from that 789, excuse me. From that 789 input layer, so either in this state, or we are giving so many number, the position has been changed to the input, it is passed to channel, so later channel, and it is passing to the, here I have 2 hidden layers. So here I am passing to first hidden layer, and then again it is passing to the second hidden layers. So here we will be applying all the pooling concepts and all, whatever the convolution part we will be performing, and it is put layer 0 to 9 values. So this new activate. Earlier we discussed, so if you look at here, the green color symbols represents So this and here and all I'm having a loopy filter. So that is reflecting in the next layer. So these neurons get activated. So we are skipping these. One layer one, and here also we will be having only some 7 to 8 number of neurons. Totally we have 784 neurons. So sorry, 784 input layers. So then we are passing to this last hidden layer. Here only 4 values activated, 4 or 5 neurons get activated. Then we are moving to the correct. So identifying it. That's it about convolution neural network. So generally to plot this is here the accuracy will be produced to make more accurate. That's all about your CNN Python code to run CNN with the database. So now I'll be showing you the Python code for this convolution neural network. So we can run it and check it. Before that, we will discuss about the procedure of this, what we have done. So in order to achieve this, so far we have discussed some of the concept behind this, but now what, so when we are working, we told like the new person or a person is very new for a programming language also can learn this very easily, like that we have discussed. So now what I'm going to do is, so I'm going to the code is, so before this, what we will be doing is, initially you skip all these things. So now coming to the experimental part, what we will be doing is, first I'm going to give my input to the system. So my input is going to be in the form of images. I'm going to do some image processing, means my input is going to be in the form of images. So I'm going to give input to the CNN. I'm talking and evaluation development. Okay, so I'm going to give my data to the system. So this is going to be in the format of image. So once I fed my image into the system, the features we talk about, the feature we to train in the machine learning, but in the deep network and all, deep learning and all, it will train automatically. So we no need to concentrate on it. So what here also, what the background scenario happen is, it will extract the feature. So it will be implemented using the filters which is within that itself. We don't want to write any code for that. We are just going to use the libraries. So far we talk about the working procedure of it. Now we are talking about how our input is going to convert as an output in a project based model. So I'm giving my input, and that input is given to the system. Once the input is captured by the system, so what I'm to do, either I can use this labeled data, supervised learning or unsupervised learning, or I can go with the reinforcement learning. Now I am telling you in general what happening over there. So once I have given my input, the features are extracted. Based on the features, so the unwanted data or unwanted information from the input will be eliminated. Only the essential information or essential part alone going to be extracted. So we are going to extract those features from our data. So after extracting that feature, I'm going to give to a modeling technique. That modeling technique is what we talk so far, convolution neural networks. There are so many modeling technique inside this. So CNN, RNN, so many neural network concepts were there. We are going to give our extracted input to the neural network or whatever we are having. So once I have given to this means, so my model is already trained a lot, so I can redo all those works so far what we have discussed. So I'll be executing all those process. Finally, I'll be getting some output. So that output may or may not be correct. So we may have misclassification also. So we will be plotting some confusion matrix for that, and we will be computing accuracy for that. We will be using performance for it. So what we are doing, I'm going to give my input. I'm going to pre-process what are the essential data I need. I'll be using that alone. And what are the unwanted or unnecessary data I'm going to eliminate. And I'm going to extract the necessary and essential features from my data, which is mandatory. The next level, what I'm going to give this extracted feature or the essential information to my modeling technique. So once I fed the information to the modeling technique, there what will happen is, each model technique will have their own algorithms, their advantages, features, advantages. Based upon our requirement, we will be choosing our modeling technique. So once the modeling technique is identified, we want to train our data and we want to test our data. Training 80% of data, and we will be testing with 20% of data. So whatever data I am having depends on the application. I'm going to vary my data size of the data. So next, what I'm going to do is, after extracting all these things, after applying to the modeling technique, I will be getting some results. I'll be getting some confidence score, or I'll be accuracy score. I can go with the precision, recall, whatever accuracy metrics I can follow, I will be using it. So in order to compute the performance of the system, we will be applying some check parameters to identify it. So more we confuse. So true positive, true negative, that things and all we will be computing. After that, we will be moving to the accuracy or precision, recall, mean square error, or whatever data we need, we will be calculating that. So that fine parameter tuning, if in order to tune the parameter, we can vary our values that I'll be showing here. Okay. So this is the outline of what happened in all the machine learning algorithm. So we'll be giving pre-input, processing or feature extraction. Then we will be giving to the, so what are the things we will be doing is, we will be giving a, so I'm giving my, and then I'm going to pre-process it, or I'm going to pre-process, or I'm going to feature. So feature extraction. So I'm going to extract the feature and then be applying some modeling technique. So in order to achieve any artificial intelligence, like want to mimic something like a human, then we want to apply some algorithm over it. That algorithm we will be using some machine learning technique. So we will be applying a modeling technique. We can apply ML algorithm or DL algorithm. So you can go for SVM, RNN, ANN, anything you can go with that. So then what we will do is we will be measuring the accuracy. So accuracy can be measured in terms of, we will be finding the confusion matrix. So what are the things we will be finding is confusion. I'll post this in the chat itself. So we will be doing reprocessing input, and then we will be doing our pre-processing, and we will be doing our feature extraction. Then I'm doing my modeling technique. I'm going to train my data, and I'm going to test data. So for training, testing and all, I'm using 80-20 ratio. So 80% of data is trained and 20% of data. With that, I'm going to compute the accuracy of the system. So to compute this accuracy, what I'm going to do is, I'm going to plot a confusion matrix. So it will be having the value like a true positive. So true positive means it is going to say the true as a true. False positive means false as true. And we are having true positive. So true positive, positive and true negative. We'll be computing all these parameters. So later we will be tuning the parameters. So performance analysis. So I'm going to tune my data. How I'll be tuning my data? I'll be varying my, if say for example, we have discussed about CNN. I'm going to vary the hidden layer. I can vary the number of weights, so and so things and all. So I'll be varying my CNN. I'll be showing you the library file also. With that, we can identify what we have discussed so far. So then we are redoing this performance, and we will be doing some classification or prediction. We will be doing a classification, or we will be doing some forecasting. So when talk about this classification, so if I'm going to categorize, either it is a tiger or lion. Okay, either it is a tiger or lion, or it is a human, like I'm identifying this as a John, either it is a John, or I have trained my data with 10 different people's means 10 people 10 different people means I'll be having 10 different people's data set under the supervised learning. So with that 10 different people, I will be having some 10 different layers as a output layer. So the output layer, see, for example, I'll be telling here only three names: John, Anu, and Arun. I'm training these 3%. So I want to identify whether it is a John, it is a Anu, or it is Arun. So I want to classify the person is who. I want to identify the person means. So I'll be giving these into the input layer, traversing everything. My output layer will be consisting of John, Arun, and Anu. So I'll be having three output layer for this. So I want to mention it in my code. I'll show you where I want to vary those things under. So with this, I'm comparing everything and I'm coming to a conclusion. That means that is going to be the classification. Classification means either this or that. Under which category it is going to fall is classification. I'm going to classify whether it is a John or Anu, or whether it is a John or Anu or Arun. So then it is going to be the classification model. Okay. Then coming to this regression model. So regression model. So regression model means you assume like it is like probability. So the value will be from the 0 to 1. So forecasting, whatever we are talking about, prediction model or forecasting, whatever we are talking about prediction model or forecasting, those things will comes under this regression model. So if there is a possibility of rain, like weather forecasting, like that and all we will be computing means that will comes under this regression model. So we will be choosing the regression parameter for that. So based on that we will be choosing our modeling technique and we are fine tuning and we are until we are desired accuracy. So here, yeah, let's come to this code. Here I have uploaded my data. So I want to upload the data. So it can be in a CSV file format or it can be in an image format. Whatever data I'm going to give, based on that, my data or value will be going to change here. So I'm labeling here. So it is a cat. The first one is cat. So I'm mentioning 1, and the second one is this is a dog. So I'm mentioning as 0. So it comes under the category of cat means the first argument is going to be my target. So that is a cat. So or else the value is going to be the 0. So here I'm labeling my data and I'm creating my training data. So here you have a pre-processing of data. So I'm pre-processing my data. So for that, I want to load my training data set. I'm mentioning where it is located. So I'm labeling all the, and I'm going to mention the path where it is located. With that, I'm going to read a particular data. Yes. So I'm going to read it as a grayscale conversion. So yes, if it is going to be RGB, then we are having some other process. So depends on the application which we are using. So next for the pre-processing here, what I'm doing is I'm resizing my data in order to reduce the burden of my system. So then I'm training here. So training randomly and I'm saving the trained data over here. Then so these are the things we have discussed. So I'm reading and I'm resizing and I'm applying it. Then coming to this part, so here what I have done is I have applied convolution. So here I have applied convolution filter. I have activated ReLU activation function. So then I have applied max pool here. So this we talked here so far. So if you want to know our mathematical notation for max pool, you can search over. Can search over. So library file in Python, like what we are going to, you want to go with TensorFlow, whatever language you want, you can go with that. Library of CNN in Python. So I can open the library file. Hang on for a minute. So Python itself, they have given that. In the Python website itself, they have given. So this is for tensor. So you can go with the, you can read from the library itself. So these are the feature map. They have calculated the value. So for this 3 cross 3, they have plotted here. Yes, this is what we discussed in the convolution layer, the filter process which we have talked about. So this value is converted and this is plotted over there. So they will be clearly explaining what is happening over there. We can go ahead with that. The library file where what we have to modify and all will be given in the library file itself. So they have given here the values. So if you want to activate this 3 cross 3, here this 3 cross 3 represent that sliding and all 3 cross 3. So if you want to make for 2 cross 2, that is 2 cross 2 pixel means you can mention over here. So here they have mentioned for 2 cross 2. So this is 2 cross 2 with slide of 2, slide value 2. So here what they have used is they have used 3 slide values. So see, look at the code for implementing this Python. It is so simple with the Terra's TensorFlow. So just they are loading the file and they are reshaping. This is what we talk about the pre-processing stage. And I'm normalizing my data and I'm defining my model. So it is going to be the sequential model. And then I'm applying the layer, convolution layer. And so convolution with the 3 cross 3 slides. So I'm going to activate reloop and the sorting I have done, and I'm applying the pooling method. So for all this, the library files has been included over here. So maxpool 2D is a library file for that. So if you type the name of this means, you will be getting in-depth knowledge about what is happening in that pooling. Let's wait for that to load. So next, what we have done, I'm just what I have done is I'm just max pooling and I'm converting my data and I'm applying dense for it to make it more accurate. I'm doing this until I found the exact output layer. So I'm doing this and I'm fitting the model and I'm displaying the result for 10 epochs. So like this only, we will be executing the code corresponding to this. So this is the procedures we talk about so far and the modeling technique of CNN which we have discussed. Yes. Anything else we want to discuss? Do we want to discuss about the library, how to get the data and how to run it? Yes. Is it clear? Yes, Kirti ma'am. So coming to the conclusion, I'll be concluding and winding up the session. If you have any doubt, you just post it here. Yes. Yes. So the things we have discussed is about deep learning and the deep learning is a technique, so where we will be teaching the computer or a machine to process the data in a way that inspires the human brain concept. So biological neural network concept has been applied. Based on that, we will be making some decisions to make it as more accurate. So this artificial intelligence is the human mimic behavior. So we will be mimicking the human behavior, or it's making the system to think like a human. So we have discussed about the advantages. So the key main advantage of this is it is more accurate and it is automated. It is applicable for automatic system or automatic teller. Some machines we are developing for that and all. We will be using this, especially for automated home automation, like Tesla car, and we can be develop it for automated vehicle, everything. So it is a scalable and flexible, it's continuous improvement. So when we are having a feed forward neural network and all, so error propagation neural network and all, they will be continuously improving their values by varying and changing the weights of the network, so that they can make it as so simple. So in order to make like a human decision, we are going to train our data. So for that, we will be using many layers, and after that, we will be applying the activation function. Then we will be pooling. So these things will be happening in the convolution neural network. The decisions will be from 0 to 1. So the possibilities are mentioned as 0.3, 0.5, like that. The category falls at 0.5 will, for that and all, our neuron will not get activated. So if I want to speak something, my speech organs has to work. For that, some neurons has to get activated, then only my speech can come. So this human principle, if I'm mimicking, means then only I can make my system to speak like a human. While you're coming to this text to speech conversion, so I'm thinking of some word from my diaphragm. So I'm thinking some word from my brain. So I'm pushing my air, and so I'm speaking. So we have vocal organs. So there is an interruption. So we have some 44 phoneme sounds. With that combination of sound only, we will be producing the output for that. So that will comes under text to speech conversion and all. So if I want to speak instantly whatever I'm thinking, I'm speaking. If system want to speak, it has to think like a human. So we are using the neuron concept. So what we will be doing is that 44 phoneme sounds will be given as input to the system, and for that 44 sounds, that 44 will be the output layer. So based on that, we will be combining the words and we are making a speech generation process. So if I want to speak, I have trillions of neurons in my running over there. So with that, what are the part going to trigger, which neuron is going to activate, which neuron is going to deactivate. If I want to move, some part of the neuron has to be activated. So that in order to make that neuron activate, we will be having some threshold value 0.5. Whatever falls under the 0.5, the neuron will not get activated. Whatever the value falls above the 0.5 means the neuron will get activated. So in order to achieve that, we will be applying some activation function. So sigmoidal curve and all will be plotting to cover the wide range of information in the data. So after applying that, I'm going to give it to the output layers. I'm going to add the bias to it. I want to activate the function. So that thing will be happening here. So in order to identify this, I'm going to categorize under which pattern it is going to come. This we see an example for number 9. If it is going to be the 7, we will be having a horizontal line, then we will be having a vertical line. So that diagonal line also we will be having. For that and all, we will be doing the same procedures, and we will be plotting, and here the loopy pattern will not come. What you will be having is horizontal pattern, vertical pattern. The horizontal pattern, vertical patterns and all will comes as a layer over here. The horizontal pattern for 7, we will be having a horizontal pattern, and for that straight line we will be having a vertical pattern or horizontal pattern. So that two layers will comes over there, and we are going to redo the process, and I'm going to identify under which category it will come. So likewise, we will be categorizing. That's it about the CNN, and we have seen the coding part of this and how it is working. So and so details we have shared. So Thank you for the opportunity. If any queries, you can post me. So do you need any clarification?
Participants, if you have any doubt, you can ask. If you don't have any doubts, shall we wind up the session now?
Yeah, ma'am. Sure, ma'am. We can wind up the session, ma'am. Yeah,
I would
thank
like to
you,
thank
Pencil Bit. Yeah, thank you so much, Pencil Bit, for offering me a wonderful opportunity. I thank Sangeeta Madam. A heartfelt thank to the Sangeeta Madam. Hope she is not in this, but she is the backbone of this Pencil Bit. And thank you, Kirti Ma'am. Yeah, thank you so much.
Yeah, I would like to thank you, ma'am, for making this session excellent.
Yeah, ma'am. Yeah. Sorry for the inconvenience which happened in the first few minutes. We had internet issue, I think so. So yes. So sorry for the inconvenience.
No issues, ma'am. And also, I would like
Okay.
to thank all the participants for this session.
Okay, ma'am. Thank you. Thank you, ma'am.
Thank you.
The feedback link has been posted in your comment box, and tomorrow also we'll be starting the section with the same link. Thank you all.